CamLogic's Tech Tuesday. My name is Dale Duell, Senior Application Engineer for CamLogic. Solid Edge.
Welcome to GoToWebinar, web events made easy.
Who is CamLogic and what do we do? CamLogic is founded in 1995, headquartered out of Oxford, Michigan. We cover Michigan, Ohio, Indiana, and Pennsylvania. We've been in business for 6 years. Or, excuse me. We have technical difficulty on this end. I think we have one open mic. We have one open mic on the other end. Bear with us 1 second.
Doesn't have any blade on it. It goes over the top of it and then cut it. And push it over to this side. That's how they do it. They run right down the road. And I was sitting there listening. I think he can do it. I was thinking 5 miles an hour. I was thinking there's 2 vehicles and another vehicle. No, rolling across.
Great. Let's get started again. We had an open mic on the other end. I humbly apologize. We were founded in 1995. We have 16 years experience. We provide dedicated customer service for engineering hardware and software. Our technology is best divided into 3 different categories: CAD/CAM, 3D printing, and 3D scanning. Our CAD, we are Siemens certified business partners, so we do the NX, Solid Edge, FEMAP, and Team Center. We also do Esprit for CAM as well. On the 3D printing side, we are a Z Corp certified partner. The great thing about this is you can design something very, very intricate inside of Solid Edge or NX and put it in the printer and actually pull the part out and hold it in your hand. From there we can do the 3D scanning. Now the 3D scanning has 2 different purposes. One is for quality or inspection. When the part comes off of the line, you can actually scan it and make sure it's all within tolerance. Or if someone gives you an older part, you can take that part, scan it, and turn it into a cloud of points, turn it back into a 3D CAD image, and then machine it, do anything that you like. Today's lesson, or today's session will be on Solid Edge surfacing, and I slipped up and I did say lesson because today is just basically general instruction. This is a 2-part series. We'll be doing surfacing part 2 in a couple of weeks, but this is just a general instruction on surfacing. I really do want all of the users to look for the 1-day seminar in a city coming near you this month. We're already scheduled for Grand Rapids, Detroit, Cleveland, and Pittsburgh. So they are happening this month. They are on the calendar. We've sent out invitations, and hopefully you've got yours. If you haven't, give me a call, contact me. I'll give you that information at the end of the session so you can get invited. Well, today we're going to do surfacing, and just in general, the idea of surfacing is best used sketch-based. In other words, we want to sketch some profiles and we want to add some surfaces and sweep and lofts and things like that. But we want to start with sketches. Also, surfacing is best done with for free-form modeling. You want to see how something looks. You're making maybe consumer goods. You're making, you care more about not its function as much as its appearance, as its aesthetics. So great for automotive industry, consumer goods, appliances, things like that. Also good for non-planar, non-analytical geometry, and that is, things aren't always perfectly round, things aren't always perfectly flat. They don't go back into the model at straight back normal. They may go back at a slight angle or even follow a path, things like that. And it's also good for repairing and enhancing imported models. Someone sends you a car door and you're making fixturing for that car door. You can actually use the surfacing to continue the shape of the car door so we don't have such rough edges, stop and start. So in today's session, we're going to look at basic swept surfaces, cross curves, revolve as reference. I think you're going to like this. A little bit of free form, and then some replace face. So without too much more work, let's go ahead and get started with this. And I'm going to start with a basic swept face. Now again, we say this is best used in Sketch. I prefer when I do surfacing to use ordered, simply because I want to go back in time and do some things. Synchronous is great for everything that we need to use it for, but when I want to go back in time and do some tweaking and twisting and things like that, I definitely like the ordered for this particular function. So I'm out in the surfacing. And let me say this before I go too much further. You can combine the synchronous and the ordered in the same environment, and probably in part 2 we'll do that. We'll actually make ordered and synchronous parts, and we'll see how they interact with each other. But I want to take this, and I've just made a sketch and a circle and a path and a little squiggly down here. So we want to sweep. And I'm going to sweep along this path, and I'm going to right-click to accept, and I'm just going to bring this down here just so you can see this. And I'm going to sweep this circle along that path. Now that's of no major surprise to experienced users, but the nice thing about it is that circle is following that path. Now, what is interesting about this is the surface is a infinitesimally thin piece of, if you will, saran wrap, that type of thing. So we're not really worried about how thick is this surface, is it the inside of the surface, is the outside, that type of thing. This is just an infinitesimally small, thin piece of saran wrap that's being wrapped around there. What's nice is I can actually, as I do this though, I can actually go close in the ends so that the ends are closed, or I can leave those ends open. It doesn't matter to me. And then we can make anything else that we like about it. Again, just a basic sweep, basic instructions on this. So I want to go run that again, and I'm going to take this and run just this single path right around there. So just that the W's or the squigglies, I just want to run this path right around there. Now, you may want to, top off a piece of automotive trim with this. All kinds of applications you can do that. But the nice thing to keep in mind when you have something like this is that we've operated based off of a sketch. So when I have a sketch, obviously, you know what I can do with this sketch. I can bring this right around, and I can make this surface follow this sketch. So I can have it any way that I like based upon what based upon my profile of the cross section and of the path that it's going to take. I can control this very, very nicely. Now, the second thing I want to talk about is the cross curve. In a cross curve, if I look at this, I have two sketches I've already drawn just for the sake of time. I have two sketches already drawn. So if I look at the front view of this, I've got this handlebar shape, if you will, or this valley coming down. So this part needs to start up here, come down, move over, and go that way. From the top, it also needs to move out as well. So we need to obey two different curves, if you will. It needs to arc out, and then it also needs to arc from the top down and over. So in order to accomplish that, out of my surfacing toolbar, I have a thing called a cross curve. Very nice, very powerful, takes a lot of the thinking out of the process. And I'm just going to make a cross curve between my front sketch and my top sketch. And as I do that, it's going to make a cross curve. I call it a composite sketch. It's about the same thing. It's going to make a composite of those two different faces. So once again, if I look at the front, I got what I wanted there, and if I look at the top, I've got what I wanted there. But now let's look at the left-hand side or even the right-hand side. You can see I've actually got a curve that matches that. Now, again, sketch-based, so I'm going to make a sketch based upon a plane normal to a curve, and I'll take this and just bring this out right to there. At this point, I'll put some sort of cross-section. In this case, it'll just be a circle. And I'll let the circle set right there. Now we'll go ahead to our surfacing. We'll do a swept surface. I will run it out on this cross curve. I'll go ahead and hit fit there so I can make sure I got it all. I'll run it out there, and then I'll just run that section across that. Again, I can cap it. This can represent a wire. This can represent anything else that I need it to be, but it is actually going to run out there and run on that cross curve, which is a composite of two different curves. So the cross curve, again, basic instructions in the surfacing, right there under my curve section right here, my curve tools, my cross curve setting right there. Now, the other thing I want to look at, as speaking as this being referenced, this can be the handrail, this can be the handlebar, this can be the wire, the big electric cable, can be anything we need it to be. But I want to work with a part that can be used as a reference. So surfacing is also a great way to use something for reference that helps me make a physical solid part. For instance, I want to take this, I'm going to make a guardrail or a fender for a tire. Well, in order for me to do that, I'm going to go take and make a revolved surface of this tire cross section about the center axis of that, and I'm just going to bring that around, and that's going to give me the outline of my tire. Well, what does that do for me? That then allows me to take something like this and then to actually do a let's take a arc by center point that actually allows me to take and decide how far around that I want this fender to go. Now, I wouldn't have known that maybe unless I had the wheel to do that with. So I'm using the surfacing as a reference point to give me what I want. We'll use a little bit of symmetric offset and just take that and have that drawn like that. It's going to go out, draw that part, and I'm going to go both ways with this piece, and I'm just going to start that fender right like that. Now, obviously, my solid part is the fender. This is going to give me what I want, but this also tells me how far around this wheel that I want to do this. And you could draw a circle, but again, that surface right there is going to show me exactly what that tire is and exactly where to put that fender. So that's going to be that's a very good way to use surfacing as well. Now, moving along quickly, we want to talk about using surfacing in the idea of mold operations or aesthetic or customer design, that type of thing. So we'll look at our revolved surface, and I'm just going to take this sketch and I'm going to revolve it right around that center, and we're going to move it 180 degrees. Now as I do, you're going to see that the part is setting out there, and obviously I'm making a glass. If you see what type of glass this is, you might understand the shape of it. You might understand what type of glass this is as well. But I'm going to make a glass out here for the customer, and I'm making just half of that glass because I want to use this in designing my mold, and we'll put two pieces of that mold together. So I have that, and the nice thing about this is as I work with this piece, I can dynamically edit this piece and just take this, and this is a function that's available inside of even solid parts as well, but I can take and move this around and give me a little more exact shape that I'm looking for. So I could take one shape, work with it, and we'll come back out and adjust it. Now I want to do a little more adjusting to that, and I want to take and convert these arcs. I want to convert them into curves. What that's going to allow me to do is I can add handles any way that I like to, but what that's going to allow me to do is to actually do a little bit of free form. So maybe I want to bring this in, or maybe I want to bring this out a little bit fuller. Maybe I'd like to take this one, and just by default we're adding one handle, one grip point, if you will, in here. We could add more, and we can talk about that in training and that type of thing, but adding more, but I get to control this form the way that I see fit. So I think we're going to leave it somewhat like this, and I think as talking about a glass, I think I would do want it to come out a little bit like that. Now that I have that, I get to go out and just sort of make my mold, just sounded kind of an afterthought, if you will, and we'll just take this, bring up my mold of whatever size that I like, and I'm going to go down and just run this down just a few inches down. Back to my surfacing, I get to go out under my replace face. I get to go out and do a Boolean subtraction. I'm going to subtract that surface out of there, and then Solid Edge is going to ask me which way did I want to remove it. I want to remove it this way, and now that mold has that glass in there. Now if you've been through my training at any time, you'll know that the mold has had the glass removed from it. The mold is based off of that revolved surface that we have, and that revolved surface is based off of that sketch. So back to the sketch and back to looking at the that dynamic edit, I'm changing my mold as I change my glass. So I get to work with this and see exactly what I want. If I'm looking at what I need, I think something like that will do just fine. I can take sort of hide that revolve, and I got the beginning of my mold right there. Now just to speed things along a little bit, I'm going to go and I'm going to copy this surface. I'm going to go copy this surface, and then I'm going to offset it. And again, I'm going to we'll take this surface right here. We'll stitch this face together. Okay, so we'll go ahead and stitch that together. And then I can go ahead and offset surfaces such as this, and I can offset that, and I'll come up here maybe the thickness of the glass that I want. I'll leave it 1/8 of an inch, and I can offset that surface. This allows me a surface to start building the other side of the die, so when this comes in, the glass is going to flow around and we're going to have a glass setting in there. So I can offset surfaces as well. We'll get into this a little more on part 2 of our surfacing. But again, I'm using curves. I'm using revolve surfaces to actually subtract this and to design my mold work inside of the context of Solid Edge. Now, the next thing I want to talk about is the replace face command. Very strong. It's under here, under the by the Boolean subtraction is the replace face. So I want to show you that, and I'm just going to do an extruded surface first, right from the sketch that I've already laid out. And I'm going to pull that surface up like that and move this surface over. So these are no more than pieces of tape, if you will, just, you know, Scotch tape or masking tape setting out there. Now, in this scenario, this is a piece of foam, and this is the inside of the car door or maybe of the dashboard, and this is the top of the dashboard, if you will, and I want that foam to go meet that. So I'm simply going to go replace face. I'm going to replace this top face with this face. And I'll do that again. I want to replace this front face, and I'll right-click to accept, with this side face right there. And that foam that I started with is now going to go up to that surface on the inside of the dashboard, if you will, and it's going to go follow that dashboard exactly the way we've asked it to. So again, very strong, very, very powerful set of tools found in surfacing. And before we close out of this, just to see that we have swept surfaces and bounded surfaces. We have offset. We'll talk next week about, or next time, about blue surf and blue dot, but I can split surfaces. I've just got many, many things that we can do with the surfacing, a complete surfacing tool built inside of Solid Edge. So very strong, very powerful, but again, just the basic idea of you can see what we've had. So today we did a basic sweep. We talked about cross curve, about taking a front sketch and a top sketch and putting those together. And we talked about revolving the surface as a reference with that tire or with something like that. That way, maybe you want to show what the fan is doing, what the fan blades are doing before you build the guard around the fan, if you like. We talked about freeform, grabbing and dragging, making customer or aesthetic products, and then also replacing face. Well, all of this comes with the training that we provide. We do basic training, we do advanced training, we do training on surfacing as well. So if you are interested in that, again, our schedules are filling up. We've always got room for more, but they are filling up. So please give us a call. The number is 248-969-9201. And these webinars that we're doing are put out on the YouTube, on the CamLogic channel. You can see those usually within a day of being recorded, and you can watch these and learn from these. We hear that many people are doing that, and we thank you for that. Again, thank you for joining us. My name is Dale Duell. Feel free to give me a call. If you haven't gotten your invitation to What's New in ST4, please give us a call, 248-969-9201. My extension is 6209. Or you can also contact me at daledee@camlogic.com, and we'll make sure that you get that. I thank you for your time. We'll meet again in a couple of weeks. I will be having some